Hey everybody! Welcome back to the channel, or if you're new here, a huge hello and thanks for stopping by. I'm really excited to share this one with you because it's the kind of story that happens to so many VW owners and can be pretty scary if you don't know what's going on. A while back I was just driving my 2018 Golf SportWagen on the highway, enjoying a normal day, when suddenly everything went wrong. The EPC light popped on, the check engine light joined the party, and bam! The car went straight into limp mode. Power dropped like a rock. It felt like the engine was barely breathing. Merging with fast traffic. Absolutely nerve-wracking. My heart was racing, I'll be honest. But I got it safely off the road, and today I'm going to walk you through the whole thing step by step. We're going to talk about what the IS12 turbocharger actually is, how it works in simple terms, what that annoying P00AF code means, and the surprising real cause of my problem. By the end you'll feel way more confident diagnosing these issues yourself. So grab a drink, settle in, and let's chat about turbos like old friends. Alright, let me paint the picture for you. I'm cruising along at highway speeds, everything smooth, radio playing, and then out of nowhere the dashboard lights up like a slot machine. First the EPC light, that's electronic power control, VW's way of saying, hey, something's not right with the throttle or boost system. Then the check engine light comes on. And almost immediately the car goes into limp mode. Limp mode is the ECU's safety net. It cuts boost, limits fuel, and holds the throttle back so you don't damage the engine. My poor SportWagen felt like it was struggling just to maintain 40 to 50 miles per hour. Changing lanes or getting up to speed was stressful with everyone flying by. I managed to exit safely, pulled over, and thought, okay, time to play detective. I hooked up my OBD scanner and the only code staring back at me was P00AF. This photo on the slide is the actual turbocharger I eventually pulled out. It looks innocent, right? But before we get into what went wrong and how I fixed it, I really want us all to be on the same page about what this turbo even does. Trust me, understanding the basics makes troubleshooting so much easier. So, what exactly is this IS12 turbocharger we keep talking about? Well, it's a clever piece of Japanese engineering from IHI. They've been making turbos for years and they're really good at it. This model is used across a bunch of Volkswagen and Audi vehicles with the 1.8-liter turbocharged EA888 engine. You'll see it in the Golf, the SportWagen like mine, the All-Track, and the Audi A3. The current official VW part number is 06K145713L, but you might run into earlier versions like E, H, or K depending on the year. At its core, the turbo's job is pretty magical. It takes energy from the hot exhaust gases that would normally just disappear out the tailpipe and uses it to force more air into the engine. More air plus more fuel equals more power and surprisingly decent fuel economy too. It's a great way to get big performance from a small engine without making everything heavier or bigger. On the right side here you can see the full IS12 assembly I removed. Look at that compressor housing on top, the turbine housing on the bottom, and the electronic wastegate actuator mounted on the side. It's compact but does a ton of work. Have you ever wondered how your turbo car feels so peppy? This little guy is a big part of the reason. Now let's get into the really cool part, the heart of the turbo, called the CHRA or center housing rotating assembly. This is the spinning core you see on the left. Inside you have the turbine wheel on the exhaust side, the compressor wheel on the intake side, a solid shaft connecting them, and some very precise bearings that let everything spin at crazy speeds. Here's how it all works in everyday language. When you press the accelerator, the engine burns fuel and pushes out super hot exhaust gases. We're talking temperatures that can hit 600 to 900 degrees Celsius under load. Those gases rush into the turbine housing and slam into the blades of the turbine wheel, spinning it incredibly fast, over 100,000 revolutions per minute in some situations. That's faster than most jet engines. Because the turbine and compressor wheels are locked together on that same shaft, they spin as one. The compressor will act like a high-speed fan on steroids. It sucks in fresh air from the air filter, squeezes it into a smaller space, and blasts that dense, oxygen-rich air into the intake manifold. With more oxygen available, the engine can inject and burn more fuel efficiently, giving you way more horsepower and torque than a naturally aspirated engine of the same size. And the best part? All that extra power comes basically for free from exhaust energy that would otherwise be wasted. Pretty brilliant, right? The labeled photo on the right shows all the major external pieces clearly so you can picture it. Here's something important though, making lots of boost is awesome, but you can't just let it run wild. Too much pressure can damage pistons, bend connecting rods, or blow a head gasket. That's why every turbo has a wastegate system to keep things under control. Inside the turbine housing there's a small valve called the wastegate flapper. When that flapper stays closed, almost all the exhaust gas is forced through the turbine wheel, making it spin faster and producing maximum boost. When the flapper opens, some exhaust takes a bypass route around the turbine. The wheel slows down, and boost pressure drops safely. The IS12 uses a modern electronic wastegate actuator, not the older vacuum style you see on older cars. This electronic one lets the ECU make tiny, precise adjustments in real time based on driving conditions. On the left you can see a great close-up of the wastegate components inside the housing, the flapper arm, the actuation arm, and the turbine wheel itself. It looks a bit complicated at first, but once you see it in action it makes total sense. This system is what gives these cars such great drivability. Let's spend a little extra time on the electronic actuator because this is where a lot of the intelligence lives, and it's key to my story. This particular unit is made by Hainan Systems. Inside it has an electric motor, position sensors, and a threaded adjustable rod that connects to the wastegate linkage. The car's ECU is constantly monitoring things like throttle position, engine RPM, engine load, and actual boost pressure. Based on all that data, it sends a precise voltage signal to the actuator. Want maximum boost for a strong acceleration on the highway? The ECU sends roughly 3.5 to 3.9 volts. That tells the motor to retract the rod, which closes the wastegate flapper completely so all exhaust spins the turbine hard. Cruising lightly. Lower voltage extends the rod, opens the flapper, and lets some exhaust bypass. There's also a closed-loop feedback system. The actuator sends position data back to the ECU so the computer always knows exactly what's happening. If the commanded position doesn't match the actual position, that's when you get trouble, like my P00AF code. The detailed photo on the right shows the electrical connector, the motor body, and the rod assembly beautifully. These things are pretty robust, but they work with mechanical parts that can wear over time. When I finally scanned the car with my OBD tool, the code that came up was P00AF, officially, Turbocharger/Supercharger Boost Control A Module Performance. In plain everyday English, the ECU told the wastegate actuator, hey, move to this position, but the feedback from the sensors said it wasn't happening properly. So the computer throws the code, lights up the EPC and check engine lights, and puts the car into limp mode to be safe. At first I was sure the electronic actuator itself had failed. The rod even looked a little bent, which made me think, yep, that's gotta be it. I started looking up prices for new turbos and my wallet was already crying. But after I removed the whole unit, tested the actuator on the bench, and did a thorough inspection, surprise. The actuator was actually working just fine. The real problem was hiding in the mechanical linkage downstream. This is such a common mistake. Lots of people end up replacing the entire expensive turbo when only a small part needs attention. Always test before you buy. Here's the actual smoking gun from my inspection. Look at this annotated photo closely. Normally that wastegate lever should rotate nice and freely around its pivot pin whenever the actuator rod moves. That rotation opens or closes the flapper to control boost. But on my turbocharger, the lever was completely seized at about a 90-degree angle. It wouldn't budge no matter how hard the actuator tried. So even though the actuator motor was doing its job perfectly, the stuck lever blocked all movement. The ECU kept seeing a mismatch between what it commanded and what actually happened, and kept throwing P00AF. What really surprised me when I took the pivot apart was how clean the stainless steel pin looked, no heavy rust, no obvious corrosion. The surface was still shiny. So it's probably not the typical corrosion from heat cycling explanation you hear everywhere. My current theory is that over many thousands of heat up and cool down cycles, plus normal wear, the pivot diameter changed just enough to cause binding. I'm still researching and will share updates later. Have any of you run into similar seized linkage issues on your turbo cars? Let me know in the comments. Take a good look at this view inside the turbine housing from the exhaust outlet side. Right in the center you can see the turbine wheel, that small fan-like part that gets blasted by exhaust gases to spin at insane speeds. To the left, you can clearly see the wastegate flapper arm and the wastegate actuation arm that connects everything together. On my car, the seizure happened right at the pivot pin between those arms. The housing itself is made of cast iron because the exhaust gases flowing through here can reach extremely high temperatures, 600 to 900 degrees Celsius depending on how hard you're driving. All that repeated thermal cycling over 100,000 plus miles is tough on moving parts. Seeing it disassembled like this really helps you appreciate how these systems work and why regular inspections can prevent big problems. Let's step back and look at the complete IS12 turbocharger one more time so everything clicks into place. On the left is the compressor housing where fresh air comes in and gets compressed. The boost outlet sends the pressurized air through the intercooler and into the engine. On the right is the turbine and exhaust housing where hot gases enter and spin the turbine. The electronic wastegate actuator and its rod are clearly visible. The inset box shows the full boost control feedback loop. ECU sending voltage signals, actuator moving the rod, lever rotating the flapper. When any single piece in that chain fails, like my seized lever, the whole system can't do its job properly and you end up with limp mode. Understanding the big picture like this is what makes diagnosis so much more effective. Before we wrap up this part, here are the big friendly takeaways I really want you to remember. Number 1, the IS12 is that reliable IHI turbo used on many VW and Audi 1.8 TEA 888 engines. Number 2, it cleverly uses exhaust energy to spin a turbine that drives a compressor for extra power. Number 3, boost is precisely managed by an electronic wastegate using specific voltage signals around 3.5 to 3.9 volts for full closed position. Number 4, P00AF basically means the ECU detected the wastegate wasn't responding correctly to commands. And number 5, and this is the most important one from my experience, the electronic actuator was innocent. The real culprit was the seized wastegate lever at the pivot pin. Always take the time to inspect the full mechanical linkage before replacing the whole turbo. It can save you a lot of time, money, and frustration. So that's the full diagnosis story from my SportWagen adventure. We covered what the IS12 is, how it works, what went wrong, and why it caused the EPC light and limp mode. But the story isn't over yet. In part 2 I'll walk you through the complete turbocharger removal process step by step from a cold engine all the way to the workbench. Part 3 will be a detailed teardown of the wastegate mechanism with close-ups of the pivot pin. And part 4 will show the actual repair and reinstallation. If you want the full written article with even more details right now, head over to acotex.com, the link is right down in the description below. If this video helped you understand your own EPC light or limp mode situation, please give it a big thumbs up, subscribe so you catch the next parts, and drop a comment telling me what symptoms your car is showing or any questions you have. I really do read every comment and try to reply. Thank you so much for watching all the way to the end. You're awesome. Stay safe out there on the road, and I'll see you in the next video. Take care, friends.